Hi, 8th graders. I hope you're having a good day.
Here's our next lesson on square roots. We're able to do operations with them, so we're going to be multiplying them, dividing them, and we're going to start adding and subtracting them too. And that last one's going to be the one that's going to take a little bit of time. Multiplying square roots, or we're going to call it multiplying radicals, is really nice because all you have to do is multiply the inside. So the square root of 7 times the square root of 3 is going to come out as the square root of 21. That's all there is to it. Square root of 11 times the square root of 6, we're going to keep that square root and just multiply the insides. 11 times 6 is 66. Square root of 5 times the square root of 2 is going to be the square root of 10. Now we should look at these and simplify them like we did last week, but of these three numbers, 4, 9, 16, 25, 36, 49, and 64 do not divide into any of these, so they cannot be simplified. Okay, so take a second and multiply these before I do. Square root of 2 times square root of 3, square root of 6. Square root of 6 times square root of 10 is square root of 60. Square root of 6 times square root of 15 is 90. Now, two of these we could simplify. So 90 down here, what perfect square goes into 90? And your choices are 4, 9, 16, 25, 36, 49, 64, 81. So that would be 9 times 10. The 9 is going to come out as a whole number. So what makes 9 is 3, a big 3. And then the 10 is going to stay forever alone inside the square root. So our answer can be simplified to 3 square root of 10. The one up here, the 60, also could be simplified. And that is going to be 4 times 15. Square root of 4 comes out as a 2. And the 15 is going to stay inside there. But when you're multiplying, the key thing is we're just going to take the two numbers, multiply them, and get that new one. Okay, so how do you think we might divide then? Square root of 26 divided by square root of 13. I'm going to have one square root in my answer with no fraction, and I'm going to just do what is 26 divided by 13, that is 2. Okay, square root of 30 divided by the square root of 5, that is going to be a square root. 30 divided by 5 is 6. I'm sorry, I'm laughing. My son decided to walk over here, stand next to me, and then fart. I don't know if you heard that on the camera or not. Square root of 6 cannot be simplified. So here are our next quick four. Square root of 20 divided by square root of 5 is 4. And that is a perfect square, so I'm just going to go ahead and do that. That's 2 times 2. Square root of 66 divided by 3 is 22, and that is simplified. Square root of 50 divided by square root of 10, I divide, and that is 5. Okay, so multiplying and dividing are the easy ones. Adding and subtracting are going to be more challenging. The basic idea is that it's like terms. So do you remember in 7th grade when we did, 4x plus 5x gave us 9x's? And we could add the x's, but we couldn't add a y to it. It had to be the same. It had to be a like term. So in this case, please notice I've got a square root of 3. I've got a square root of 3. So I'm going to add them together. 4 of these plus 5 of these make 9 of the same thing. So it's 9 square roots of 3. So if it's set up like this, it's going to be nice. It's going to be just go ahead and add them, keep the square root. But now in an example like the bottom here, that's square root of 5 and square root of 6, and I cannot add those. So that cannot be simplified. So looking at our next one, we usually do like 4 pieces here so that you have something a little more interesting to put together. I'm going to look for the ones that match. So please notice I've got a square root of 11 and I've got another one. So I could put those two together, the 5 square root of 11 and the 8 square root of 11. I'm going to add to 13 square roots of 11. And then I've got this one that's a square root of 2 and this one that's a square root of 2. So I can add those. 7 of them plus 2 of them makes 9 of that same thing, that square root of 2. I need a sign in between them, so please don't forget to use whether it's positive or negative. In this case, it's a positive 9, so I'll use a plus. Okay, please look at the bottom 4 here, and right now I cannot add any of these together because none of them are the same. Look up here how I did the 11 with the 11. Down here, I don't have any that match. Nothing matches a 75, nothing matches a 50. So what we add in is a step where we need to simplify. So we're going to do like we did in the last lesson, and we're going to try to figure out something that goes into 75, 50, 300, 162. And it's not going to be the same thing. It's going to be different ones. So what goes into 75 from my list over here? So 75, that's going to be 25. So that's going to be, how many 25s? That's going to be 25 times 3. What goes into 50? From my perfect list over here, 1, 4, 9, 16, 25, 36, that's also going to be 25. That is 25 times 2. Okay, our next one, 300. What goes into 300 from our list? Hopefully that one's clear to you. 100. That's going to leave 3. And then the last one here might not be obvious to you. 162, that is 81 times 2. Okay, so I'm going to simplify all these. So what makes 25 is a big 5. What makes 25 is a big 5. What makes 100 is a big 10. What makes 81 is a big 9. And all those other blue ones are going to stay inside. So that 3, that 2, that 3, and that 2 are still going to stay inside. I also still have my pluses. Okay, now I can pair them up because now I do have ones that match. I have this one, this 5 square root of 3, and this 10 square root of 3 is going to make 15 square roots of 3. And then I've got this 5 square root of 2, and I've got this 9 square root of 2. Those are going to make 14 square roots of 2. And please stop there. It looks like you should be able to do more. That looks kind of like a complicated answer, but that 3 and that 2 are not the same, so we cannot combine those together. Okay, so that is our process. We look at it, we see if there's anything the same, and right now there's nothing the same. And these questions have been carefully crafted so that when you are done simplifying, they will have ones the same. So it should always work out. We are looking down our list of perfect squares. Which one of those goes into 28? So I'm going to start from here up because it can't be bigger than the number 28. 1 doesn't really matter. 25 doesn't go into it, 16 doesn't go into it, 9 doesn't go into it, but 4 does. That is 4 times 7. Okay, now I'm hoping the 700 is nice and obvious to you, and I should mention 25 does go into 700, but we're looking for the biggest one that does. The biggest one that does is going to be 100. Those hundreds hopefully stand out to you. 100 times 7. What goes into 20? So 16 doesn't, 9 doesn't, 4 does. 4 times 5. What makes 45? That is 9 times 5. Okay, we're going to go back and get our perfects out. So square root of 4 is 2 times 2. Square root of 100 is 10 times 10. Square root of 4 is 2 times 2. Square root of 9 is 3 times 3. And then those leftovers have to stay inside the square root, sad and alone. We still had plus signs in between. And for the record, I don't think I have an example here that has subtraction, but we would do the same thing as we would just subtract our final answer. So what matches here? Well, these two are both square roots of 7, so let's put them together. 2 of them and 10 of them makes 12 square roots of 7. These two go together. So let's put that 2 and that 3 together, calling it 5, still square roots of 5, and I need something in between that is a positive there. So 12 square roots of 7 and 5 square roots of 7. Oh, sorry, 5 square roots of 5. Our last one here. None of these are the same, so we're not going to add them as they are. But I'm going to look for what perfects from this list goes into 900. Hopefully I can hear you yelling, that's 100. 100. Oh, do you know what? I was just going to write 100 times 9 in blue, but 9 is also. So this one is perfect. It is 30 times 30. Okay, so what makes 27 is 9 times 3. So square root of 9 comes out as a 3. That other one is going to stay inside there, so 3 radical 3. What goes into 12 from our list? Well, we're not going to do 16 because that's too big. So ask yourself, does 9 go into it? No. Does 4 go into it? Yes. And there should always be something going into it. We don't give you problems that don't have something that works out. Square root of 4 is 2. And that 3 is going to stay inside there, still at the plus sign. And lastly, the 32 is going to be 16 times 2. We always want to go with the biggest one, and 4 does go into it. But if you wrote 4 times 8, you should notice that 8 could be written as another 4 times 2. So let's just put those 4's together and call them a 16. Okay, square root of 16 is 4 times 4 with the 2 inside still. Plus sign on there. Then we would look for what goes together. So this 30 has nothing that matches it, so it's just going to sit out front. But these two are both the same, so I'm going to add them up. 3 plus 2 is 5 with the radical 3, a win. And then the square root of 2 will have to be on the end down there. Okay, the homework is going to be 7.5. Give it a try. Again, to summarize, multiplying, just multiply the insides. Division, just divide the tops. Adding, you need a common denominator, and that's where you might have to do a bunch of work here to get one that matches. So I've got one of those on the homework for you. All the other ones are the nice ones.